Thank
Thank
you.
you.
Hi, everyone. Thank you so much for joining. Sorry for a couple minutes late. My co-presenter is having trouble getting in, but we're going to get started anyway. Like Ruth mentioned, I am Ashley Ruiz, and my partner, Dr. Manaya, will be here in a minute. But we work for the Snap Inc. Institute for Technology and Education at Cal State Dominguez Hills. And our mission at our institute is to make high quality, standards aligned computer science an integral part of all learning experiences for K-12 students in the county. So we're excited to share how we've expanded early access to computer science through a partnership model that we've developed between Dominguez Hills and local elementary schools. So we'll share our model with a focus on practical integration, equity, and collaboration. So here's what we'll cover today. We're going to start with why computer science ed matters, especially for really young learners. And then we'll take a look at some of the challenges. We'll share our partnership model. We'll walk through some subject-specific computer science integration examples that hopefully you can take into your own classrooms today. And we'll close with some free resources and time for questions. So by the end of today, you'll understand why early computer science education is critical, see how a school-university partnership model can support it, and walk away with real examples and resources to integrate into your classrooms. So we're going to start with a quick poll. Go ahead and scan that. Let me start it first. Oh, yeah, go ahead and scan that with your phone. And this is a picture of some of our work with our kindergarten students we work with in computer science while you're taking a snap of that. And you've got a couple questions. So what grade do you currently teach and support? And then there's a couple more questions. So take a couple minutes and complete those questions. Yay, elementary. You're in the right spot. Let me get the link. There it is. To elementary, yay. Okay, we'll take about 1 more minute. The link is in the chat. Oh, yay, preschool, perfect. Higher ed, wonderful. Okay, it looks like we've got the right group of folks in here. Excellent. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we got a couple preschool, a couple elementary, we got a higher ed. Roles, future teacher. Yes, please vote, please vote. And the next question, my role is for my faculty. Where are you coming to us from? Can you put it in the chat or you can unmute? Oh, two faculty. Great. Okay, teachers and faculty. And what about experience with computer science? Anyone currently implementing computer science? East LA College, wonderful. Thank you, Elvia. Yay, one person already integrating. Wonderful, wonderful. What? No, that's okay. Hopefully today we can get you going. Wonderful, wonderful, wonderful. Okay, nice little mix. All right. Well, hopefully what we share today will be things that you can take back to your classrooms. These are perfect for preschool and elementary classrooms. So like I said, you're in the right spot, and thank you so much for attending. So first we're going to talk about why computer science matters and what it is. Okay. Oh, here is Maya. And it says
Yes,
Nicole
hi.
Reynolds. Okay. We'll change your name in a minute. But there's Dr. Manai right there. She will go ahead and take over. Are you good, Maya, or
Yes,
you want me to
yes.
go?
Um, let let me get started. Yeah, no problem. I want to introduce myself. My name is Maya Minai. I work with wonderful Ashley Roos here. She's been my colleague for the past few years, and we've been working together on expanding computer science in our elementary levels to make sure our students have opportunity to experience computer science. So why is it important? Why do we want to expand computer science experiences in early education as early as elementary? Well, we want to make sure our students build confidence early on. We want to make sure that we support them in learning important content areas such as math, science, and expand their literacy skills. We also want to prepare them for our digital world. We want to make sure that they're just not the user of application, but also the creator and thinker and maker of those applications. So what we are going to describe computer science here, we're going to approach it as either a plugged coding activity, or it can also be used and taught as an unplugged activities. We are going to describe it as a way to problem solve, use our creativity and logic to go through the process of computational thinking and problem solving. And through that, we want to describe it also as a way for our students to be creative and the future problem solvers. If we look through our data, if we look through the literature, if we look through our students' participation, we are seeing a huge equity gap existing, particularly in areas for computer science education. So even though at the local, state, or even national level, we are pushing to include computer science in our classroom, we are still seeing a huge gap existing still within this field. We are not seeing a lot of our students pursuing careers in this field, and with that coming out as a huge equity gap, national initiatives have been pushed through organizations such as Code.org, NSF, Computer Science for All, expanding Computer Science Education Pathway Alliance, another great organization, National Center for Women and Information Technology. They've all have worked really hard to emphasize why is it important that we need to expose our students to CS as early elementary level. So this focus on students, really we want to see a shift. We want to see more representation in K through 12. We want to really create opportunity for all of our students, even our non-English students, to be able to go out there and try this out and really see the potential. So these organizations are really, really pushing to really make that shift, which is currently represented in only typically white, suburban male English-speaking students. They want to make that shift towards a more diverse, particularly culturally and linguistically diverse students. On the bottom of this slide, you see a lot of work and emphasis being done by those organizations that we thought that we would want to share with you if you would like to read more about what these organizations have done. And I'm going to pass it to wonderful Ashley for the next part.
Okay, so now we're going to talk about the future of computer science education. So here is a graphic of the United States from code.org in 2024, and it represents the percent of high schools offering computer science by state. Okay, this just means that they are offering it. It's not required. It doesn't mean that it's a graduation requirement. It just means that it is being offered. So even though California leads the world in technology innovation, we're still behind when it comes to computer science ed. Right now, only 52% of California high schools offer at least one computer science course. Okay, 52%. When we compare this nationally, we see states like Arkansas, Maryland, South Carolina nearing 100% of high schools offering computer science. And many of the states with the higher numbers, it is a graduation requirement. Okay. So other states are moving aggressively towards universal access to computer science. California's 52% is a strong step forward, but like I said, there's quite a ways to go. There is now quite a bit of pressure at the state level to expand computer science access. There's new legislation that's trying to get it offered at least in all California high schools, but it's been met with some resistance. So, you know, in the future, it might be coming. We're just not there yet. And this push isn't just about offering coding and robotics and those types of classes. It's really about preparing all students from the earliest grades to participate in a meaningful way in our rapidly growing digital society. If we wait until high school, I know for myself, like if I would have been introduced to computer science in high school, not being exposed to it at all before then, I would have had a really hard time. Okay. My daughter's the same way. She's 12. She's never been exposed and she's just not interested. But I wonder what that might have looked like if in preschool and in kindergarten she was exposed to computer science. So, like I said, if we wait till high school, it's a bit too late. We lose a lot of our learners during that time, especially our girls, our students of color, those that are typically underrepresented. We are seeing an uptick of middle schools offering computer science, but like the research says, and Maya was explaining, the earlier we can start, the better. So another issue we run into when we talk about expanding computer science ed is teacher preparation. Okay. So according to the research, a significant challenge in expanding computer science ed is that many teachers, especially at the K-8 level or the multiple subject level, haven't had any training or support to integrate computer science into their classrooms. Um, and here's something surprising. In the state of California, where we're leading the tech industry, right? Teachers can teach computer science without any training. So everyone here, you don't need training. You can go teach computer science. But as you can imagine, without the proper training, it's difficult to be consistent in our application of the computer science standards. So this really makes it challenging. In the chat, in any of your undergrad or credential programs, did you have any experience with computer science education integration?
And feel free to unmute if you want to just voice it out.
Yeah. I know for me, no. Okay, Tia is another no, but it was a no for me. Back in the early 2000s, it definitely was not a thing. Okay. Oh yes. Okay, nice. 20 years ago. Very good. Oh, James has a degree in computer science. Wonderful. Okay, so we've definitely got some folks that are prepared, but Tia, I'm with you. I didn't receive any training, so it's been difficult. There is a computer science supplemental authorization that the state has offered, and we offer it at Dominguez Hills, so I took that, and it's really helped me in integrating computer science into my lessons. Okay, so we are running short on time, so we are going to skip. Oh, we have a couple minutes.
Yeah. So
Yeah.
we really want to, since we've been doing a lot of the talking, we really want to invite you to think about, is there any CS opportunities, maybe at your school site, even your school district? If there is an opportunity, what are those opportunity? Or do you see any potential for growth or roadblock if you want to start integrating CS in your class? So we see.
Yeah, maybe I don't know if you're in teacher prep at the faculty level, but maybe you can share if computer science is happening in your credentialing programs.
So we have Elvia saying that it may have to do with the BA/BS degree option that includes computer science as requirement. So for us, for me, I've taught preparatory credentialing courses, both for elementary and secondary. And there is a push to think about integrating technology within the lesson that our candidates produce and create and implement. And if for someone like me who does have background in CS, I always push my candidate to think about integrating computer science. So potentials there, yes. If you want to blend it in with integration of technology, you can certainly think about, okay, now how, where, which part of my lesson can I engage my students to think about solving a problem, taking this problem apart, looking at the pattern, then proposing a solution. All those steps that students are required to take in order to develop their problem solving skills, their computational thinking skills. So that there is a potential from the work I do right now as someone who's actually teaching method courses or teaching credential courses for our pre-service teachers. So think about that. I mean, some of you might have already implementing computational thinking in your lesson when you're designing your lesson,
You
inviting you.
probably are without knowing it.
So think about that when we are inviting you to think about ideas, potential growth. And if I'm gonna be quiet for a second, let you think about this, and if you want to share those thoughts, please feel free and unmute, or more than welcome to put it in the chat box. Where do you see potential and growth, or where do you see equity showing up in your work? You want to think about those questions additionally going further.
Also want to mention those of you that are undergrad and getting a credential right now, if you're considering computer science as something interesting that you wanted to teach at the middle or high school level, if you have a single subject math, single subject business, or single subject industrial technology education credential, you automatically can teach computer science at that grade level. Okay. So you do have to have one of those credentials to teach it at the high school level. Middle school, it kind of depends. It depends on the district and the school. But at the high school level, for sure, you have to have one of those degrees. And there isn't a computer science credential. Okay. There's an authorization that you can add to your credential. But like in elementary school, if you wanted to start integrating computer science into your lessons, you don't need it. You
Mm-hmm.
could just do it. Anything to add before we move on? And feel free to add stuff to the chat as we're moving along. Okay. So thank you for taking a moment to reflect a little bit. We know that for some of us, the lack of teacher preparation and time has been a challenge, especially when we see computer science as one more thing to teach, right? We already have to teach all of these things on the slide. How are we going to have time to also teach computer science? Well, our approach at the Snapping Institute for Technology and Education is to embed computer science into what teachers are already teaching. Okay, and we do this through a school university partnership that's collaborative and practice based, and it serves as a PD to help teachers learn how to integrate computer science into their classrooms. So here's what it looks like in practice. Rather than treating computer science as a standalone that you've got to block out a part of your day to teach, we work with classroom teachers to integrate computer science into core content areas like math, science, ELA, social studies, art, and even ELD. There's opportunities for all of those areas, and Maya's going to show you some examples of those in a bit. We help teachers connect computer science concepts like algorithms. We do a lot of algorithms at the elementary level. Sequencing, you probably do sequencing in your lessons at the elementary level already. Logic and data collection, maybe you do some of that in science already or math. But this content is stuff that is already being taught. So it's really easy to just integrate some computer science and coding concepts along with those topics that are already being taught throughout the school day. Okay, so this approach not only makes computer science more accessible to students, it also makes it more manageable for teachers. Okay, so our approach allows pre-service and in-service teachers, so students and teachers that are already teaching at a school site, to work together in a real-world classroom-based context, and we'll talk more about that on the next couple slides. All right, so this is our model, and this is how it's involved. We've talked about the lack of teacher preparation, the lack of early access. This is kind of our solution, okay? So this model is built around a university school partnership that brings together higher ed faculty and staff. Maya and I are two of the members there. And pre-service teachers. So teachers that are in our College of Ed that are obtaining their liberal studies degree are part of our model. Okay, and we also work with in-service, so teachers that are already in the classroom teaching at the elementary level. So what makes our model different, you might be wondering? Well, it's not a workshop, okay? So it's not something where you need to be pulled from your classroom to attend this workshop and you have to make lesson plans and things like that so that you can attend. It's not a bunch of extra curriculum that you're gonna need to implement. Rather, what we do is we bring together teachers with our team, and we develop lessons that align with the current curriculum that they're working on. So in this model, each group, the university and staff faculty, which is site, the in-service teachers and pre-service teachers all bring something different to the table. Together, we design, prepare, and implement computer science activities that are meaningful, inclusive, and connected to real classroom goals. So over the next few slides, we'll take a deeper look into the role of each of the team members. Okay, so our university team, which Maya and I are part of, we play kind of the central role in both the design and coordination of the professional development, which ends up being a computer science event, okay, for elementary students. So we work behind the scenes and alongside teachers to ensure that the event is inclusive, standards aligned, and sustainable. Really important that it's sustainable, because what we want to do is model for them what they're going to be doing in their classrooms, and hopefully they carry it on when we're not there. Okay, so we begin by developing activities. We design these activities that are not only developmentally appropriate, but also aligned with standards. And we often integrate them with core concepts like science and math. That's been the biggest ask of teachers that we've been working with so far. To prepare facilitators, which are our pre-service teachers, we create training resources, include videos, slide decks. We give them ample time to practice the activities before they do them. So as you're gathering, the pre-service teachers are the ones that actually facilitate the activities at the event. Okay, so they're getting practice as well, but we create the materials for them. We recruit and train and coach our pre-service teachers throughout the event. We head up the setup, logistics, all of that great stuff. After each day, it's typically more than one day. Sometimes it is just one day, but we always do a lot of reflection so that we can improve our work for next time. So if it is 2 days apart, we'll reflect, and if we need to make an adjustment for day two, we do that. And beyond this event, we really work to improve our partnerships with our local community and our local elementary schools, which we think is really the best way to expand computer science access and ed by leveraging both of the resources. And finally, our work really is to support teacher capacity when it comes to computer science ed. So when it comes to the in-service teachers, their role is to work alongside us. They help identify curricular connections. So for example, we were just working with a kindergarten team. They were studying life cycles and learning about different environmental factors. So we decided to work with our Bebot robots and do some lessons surrounding, the different science aspects of bees. So they provided feedback. So what we do is we take all the information for them, we design some activities, we let them decide which ones that they like, and then they give us feedback if any changes need to be made. At the events, they are observing. So they bring their classes and they observe while the pre-service teachers are facilitating the events. They help with classroom management as needed, but for the most part, they're observing and just taking it all in so that they can support this work moving forward. And then, our work is ongoing. So we're a constant open door to them. So if they need additional support, want us to come back, want to borrow robots, we're more than welcome to do that for them. And the last piece of the puzzle is our pre-service teachers. This is a gap in many universities that we have found. A lot of universities, like we saw in the chat, some do, which is great, but others don't integrate computer science into the liberal studies track or any of the methodology courses. So one of our team members teaches the STEM class in the liberal studies pathway, and he recruits teachers from his class to come facilitate the event. So they participate in pre-event training. They review the materials and guides ahead of time. They come to the event early and practice with their peers. And then they actually are the ones that are leading the show. So they are facilitating the entire event. So they're getting firsthand experience. A lot of times it is their first time in the classroom. So they're getting experience with classroom management, they're getting experience working with others, but they're also getting those foundational computer science integration strategies that we hope will carry on with them throughout their teaching careers. So the outcomes that we hope for in our model are that we're building capacity. Okay, that's number one. We want to build capacity. We want teachers to be doing this when we're not there. Okay, we want them to see, oh, in science, we're doing this. Might be a good opportunity to talk about algorithms or talk about logic. So just finding those connections where they can build in computer science. For the university team, really the outcome is a refined, replicable model of equity-centered CS professional development that doesn't look like a traditional professional development. And for in-service teachers, it's really that firsthand exposure to what inclusive computer science ed looks like at the elementary level. And of course, not to, forget the students, but they also benefit, right? They get their first opportunities a lot of times to play with robots and learn about algorithms and, approach science and math in ways that they're not used to, which is really exciting. So these outcomes across the roles are what make this model effective and also sustainable and scalable. So Maya will start us by talking about computer science integration.
Yes, thank you so much, Ashley. So we asked you to think about, well, are you using CS in your class? Or if you haven't, or you thought about including it in your lesson, there are many, many ways and support and resources you could use to start integrating computer science into your content area. Remember, computer science is not just for math or science courses or content areas. It can be integrated into art, into English language arts, into social studies, even physical education, believe it or not. So we will review, as much time as we have, we will review some ways for you to align your standards with the CS concept and standard. And really the goal is to let your students know that they can actually use computer science, computational thinking, and they can actually apply it across various disciplines. For math, there is a lot of wonderful resources in Scratch. I am going to put that MIT website in our chat box here. So one thing wonderful about this resource is that a lot of these projects have been made by students. So you can explore, browse to go through, see through these projects and maybe just get an idea to incorporate it into your unit plan, for example. For Scratch, in terms of math games, there's a ton of algorithmic approach that you can actually implement. There is a classification number for even odd multiplication. Another resource is Microbit. Microbit is actually a wonderful resource you can use to collect real, raw, real world data, such as the movement number, such as temperature change, such as elevation change. All that can actually be used to build a set of data that students can actually analyze and look at the pattern changes as they change the variable. For moving forward after math, there are also wonderful resources for science. The basic one that I could look through in Scratch, again, if you go to that website I put in the chat box and just in the search box, include the topic that you're actually implementing in a few weeks or even tomorrow or day after. See what sort of project have been made. Some of these projects that have been made by students also include directional documents, background information. All those have been provided by their teachers. So feel free to take a look at those. Ton of stuff about ecosystem, ton of stuff about nitrogen water cycle and how students created those projects that are relevant to what they know, the prior knowledge they bring into the class. And it's really interesting to see how they put a spin into creating those stories and projects and animations, showcasing their knowledge about all these wonderful concepts in the content of science. Social studies, wonderful way for Scratch for you to explore this content area is to think about historical event, historical important dates out there, and really creating animated timeline. Storytelling comes into play in here, digital storytelling using both Scratch and Scratch Junior or even Thinker to really showcasing the cultural and historical changes in previous states. For moving forward to the other two content area, language arts and art itself, you could actually use code-generated art to show loops and pattern to help students see the relationship between the two, how they can actually be manipulated and changed. Again, ton of projects in Scratch Junior if you are teaching elementary, which I'm guessing most of you are teaching elementary level. So Scratch Junior is a wonderful resource to use. Let students use computational thinking and using code and writing, listening, speaking to tell a story. So really you're having them practice all these skills while also engaging them in the process of computational thinking.
And Maya, let me just jump in. Scratch Junior is a great starting place. Like if you're interested in exploring, it's free. It's an app that you can download on whatever device. It doesn't need Wi-Fi. You don't need to log in. It's a really great way for kids to start learning about block-based code.
Yes, absolutely. So if you are teaching elementary, definitely start with Scratch Junior. And if you are teaching upper elementary, fourth or fifth grade, if you think that your students are ready to go a little bit further into a more advanced project, then you can actually move to the Scratch project that you can explore those to see how you can bring those into your content area. So it all depends on your students' level, your students' needs, and what you are covering in terms of your content area. We should not forget about our English language development and our wonderful ELL students. There are a ton of additional resources that you could actually use to help them develop their language acquisition in terms of listening, speaking, writing, and reading. In terms of learning important vocabulary for your content area, there are digital flashcards that they could actually create by embedding audio, by embedding words or images, really creating these simulation to have conversational storytelling where they can actually develop those, develop English language acquisition in their project. So interactive storyboard, I've actually had some experience creating those with elementary kiddos. They really enjoyed the fact that they had option to create something that they wanted to, for example, give to their parents, give to their best friend. So they created this digital story board, and they could actually digitally send it via email to their mom, to their dad, or to their siblings, or even to their best friends. So they created this little project about who they are, what they enjoy to do at school, what is their favorite subject, what they've learned, in, for example, in their favorite subject, the latest topic that their teacher actually covered. So the bottom line is that doesn't matter what content area you teach, there are a ton of ways that you can bring in CS into your classroom. So you want to be able to, for example, if you're teaching English language art, you want to bring in ideas around maybe sequencing and logic. You want to bring in narrative writing into creating those digital projects. If you are specifically teaching very STEM-focused courses like math, science, and computer science, the important areas and skills that you can think of developing could be problem solving, could be modeling, could be data collection and data interpretations. Always remember, you could also start just by leveraging computational thinking skills and bring those into your classroom. Right now, next, my colleague Ashley is going to introduce you to some of the work we've done with elementary kiddos and their teachers and walk you through some of our projects.
Okay, so this is a computer science activity we did with kindergartners. I'm going to be giving you access to a resource library of all of our activities. So if you want to try this in your own classroom and have access to Bebot robots, you're more than welcome to try it out. And so what we did was introduce students at the kindergarten level to the term algorithm. And algorithm is a list of steps to complete a task. And that's a lot of what computer science is, clear, logical steps. So here they're drawing arrows to create a path. So they have a little cone that has a hive on it and another one that has a flower. Their bee has a little cart on it. So what they're doing is collecting pollen from the flower and putting it in the cart and then creating an algorithm to get the bee robot from the flower back to the hive so it can make honey. Okay. So as you can see, computer science, right? We're doing the algorithms, list of steps to complete a task, but we're also integrating bee behavior and what bees need and how honey is generated and different aspects of science. So here's a little video of a couple of our friends.
4, 5, It's so close. It's so close. It's so close. You got it. Good job, Athena. High five. Give me five. Good job, Sebastian. Okay.
So that was after some trial and error, but you could see how excited they get when they are able to get their algorithm to correctly work, right? And get their bee from the flower to the hive. And then of course we move the cones around and make it a little more difficult as they understand the concept and it gets a little bit difficult. But it's interesting very much to see their thinking, right? If it didn't get there, then you can see them taking steps backwards and thinking, okay, well, we did set, that's why they were counting the steps, right? Okay, 7 steps up. If that's too much, then the facilitator, which was a pre-service teacher, would ask them, okay, we did 7 steps up. Was that too many? Was that not enough? So that they're really thinking about the process. So that is one example. Here is another example. This is more for upper elementary, but they're also using the bees. This was actually a 4th grade class. So you can see our pre-service teacher here on the left and the students on the right. And we have these vinyl mats and they use the bee bots to do a challenge. So they were learning about environmentalism in their 4th grade class. So what we did was create a challenge where they were using electric vehicles, okay, to save conservation of energy and resources. So on the maps, we have a level 1 side and a level 2 side, but there's different tasks. So they have to get from home to school, and they have to charge on their way there and or on the way back. They have to avoid the different traffic, the parks, the construction on their way. So as you can imagine, this creates a more sophisticated algorithm than what it would be for the kindergartners that we were working with. And the Bebot, if you can see just on the top of it, all it has is forward, back, right, and left. Those are the only buttons it has. Okay, it's a very simple robot and very simple to navigate. But it could be used, you know, throughout elementary school. It could even be used, we've used it in preschool as well. So it's definitely preschool ready to work with as well. Okay, so here again, they're learning the term algorithm, list of steps, and they can draw their algorithm here as well, because a lot of these ones get pretty lengthy, especially if they're going to school and coming back. And the last one is using our Dash robot, which is a different type of robot. And it uses an app called Blockly, and it syncs up and they start to learn block-based code. Okay, so the block-based code is what moves this robot. We use this for upper elementary. It's a little more difficult. The kindergartners, it's not really appropriate for them. But so they use an iPad that has Blockly on it and they use it to control their robot. So here's an example of that.
So now we need it to go back. So it's like
Backwards and then backwards. Yeah, what would we do now?
So they're getting from home to school, and then there's various different roadblocks in the way that they're trying to avoid. So those are some examples of what it looks like, and you'll see in each of the pictures, there's a pre-service teacher. They are the facilitator of the event. And if we did a wider background view, you would see the in-service or the teachers of these actual classes kind of walking around and taking it all in. So here is a QR code if you want to scan it for our resource library. It's constantly growing. So I actually have some more activities I'm going to be adding on there soon. But go ahead and take a look. It's if you click on each of the grade levels, it will give you access to the different activities. Some of the grade levels we don't have activities there for yet. Okay, like 3rd grade, for example. But there are some for TKK, 5th grade, and 4th grade. Okay. All right, and Maya will talk about some more resources.
Yes, so those are some wonderful resources to look through. Again, as Ashley mentioned, all these were put together with the collaboration between our team and the elementary school that partnered with us to walk us through what they're covering in the class, what themes, for example, should we integrate when we're designing activities for their students. In addition to those, there are additional CS resources and curriculum out there. These are just a few examples. I'm sure if you do your own research, you will come up with a lot more, but the most commonly and versatile one that we could find, that we find it very helpful, are these selection of curriculum and resources. Some of these include already made lesson plan, students worksheet, and really includes standards in terms of connecting it to your specific content area. I put the link in the chat for you. Scratch and Scratch Junior link for those have been provided earlier in the chat. I believe Ashley also included the Scratch Junior website in there along with the Scratch. The whole purpose of this is for you to explore these and see what works best for you and your students. So you may explore some of these, and out of these 6 tabs that you see on this screen, only maybe 1 or 2 is the one that you actually think may work in your class. And that is totally fine. You want to start with those, see how your students will react. Are they going to be liking the activity? What modification will you be able to make? And really set you start at a starting point rather. In addition to those, we also included some framework for you. We believe that for some of you who want to go one step further and say, hey, I want to see some sort of a progression chart to see how my content standards aligns with computer science standards. We have also included computer science for the K through 12 framework in here. There is computer science standard for our state of California for the K through 12. And actually, yes, thank you so much, Ashley. So you put the presentation up there. So you can access these. These have been hyperlinked within the presentation. So you're able to maybe just save the presentation. And by that, you can hold on to these wonderful resources that you see. But these are some of the resources that we think is going to help you get a head start if you want to start incorporating CS in your class. We've also included a list of references for you to take a look at. There are quite a few, but we believe that if you want to read further into these researchers, read further into these statistics, they're really eye-opening. They really create this urgency for all of us to start incorporating computer science into our classroom. I want to thank you all for sticking around and really listening to what we have done and with computer science at site CSUDH at Cal State University Dominguez Hills. These are contact information for both Ashley and I. We put our site website also up there for you. The site resource library that Ashley shared earlier is also included. The link for that is also included in there. Thank you so very much for being here, and it was really wonderful presenting our work to you all.
Before I turn it over to Ruth, if anyone is interested in a computer science supplementary authorization, so you have to have either a multiple subject or a single subject and are interested in adding on this authorization, Dominguez Hills actually offers it for free. So I'm going to put the link in the chat. While Ruth is closing us up, we're going to stay on. So if anyone has any questions, feel free to stay on after Ruth shares some info. And I'm also going to put the flyer for the CSSA computer science authorization in the chat. So take it away, Ruth.
Thank you, Ashley. I hope you don't mind if I share my screen. So I'm going to replace this current share.
Sure.
All right. Everybody get your cameras or whatever it is you need, and go ahead and scan that QR code to tell us how you like this session. And also I will put the tiny URL in the chat, and that will also, if you fill that out, that opportunity drawing will, it's a survey. You tell us how you liked the session, which was amazing. I learned a lot. Reminded me of the old Apple days when we had that little green arrow where we taught the students to go forward and go left and go right. Back in the 80s, I'm dating myself. But as you complete the survey and tell us what you liked, you'll be entered into the daily opportunity drawing, and you don't even need to be present to win. You'll get notified. And I would also like to bring your attention to our upcoming sessions. At 1 o'clock, we have Building Sustainable Teacher Preparation Pathways from Irvine College. We have Be Authentic, Empower Today, Tomorrow, and Transform Tomorrow with Crystal Clear Academics. And we have One Classroom, All Learners. And that one is about full inclusion. And I'm going to put the schedule in the chat as well. So if you heard of any that you liked from those, you can click right on that schedule and get the links and register. And that's all I have. I hope you all are filling out that survey before I stop sharing so that I can turn it back to our presenters. So if there's any last minute questions.
And our contact info is on the slides as well, on the last slide. So if you think of any questions or want to start integrating and want some useful tips, we're more than happy to help. Just reach out. Oversized IBM computer. Oh yeah. Oh yeah.
Yeah, we had those Apple ones. And then I was one of the first teachers to get the Macs, which was crazy.
Oh yeah. You were
It's
fancy
nice
though.
to remember those early beginnings.
Yeah.
It really is. Look at how far we've come. It's just amazing.
Yes, right? And that we're now exposing preschoolers to this stuff. So just crazy times. Any questions? Yes. Yes, Elvia. I wish others were encouraged to as well. But what a great gift if we can offer it in elementary school and it doesn't have to be a college level class, right? That we're leaving elementary school and middle school and high school with the computational thinking skills.
Just a heads up, everybody, we're gonna end the session in about a minute. So feel free to drop any questions or anything in the chat. Otherwise, we're gonna close the meeting very soon and give you some lunch time and look forward to seeing you all in the next sessions coming up at 1 o'clock.
Thank you, Ruth. We had fun.
Thank you, everyone. Take
Once we
care.
got Maya in.
Yes, Amaya. Thank you.
Thank you. Thank you so much.
Thanks,
Have a great
Maya.
day.
Take
Thank you.
care.